Okay, this is the first video on energy, and to stop myself from rambling all over the place, I'm going to try and stick to my to-do list here. So I'm going to start with what is energy and what is work. These two things are pretty closely related. So I think a good place to start would be to give you the definition that I grew up with for energy. And energy is the ability to do work. Okay, so that might not help you too much, but maybe you're familiar with the idea that work is force times distance. So if we think of it this way, if something can move something some distance, then it must have some energy. So energy is the ability to do work. And if you want to think of it like that, anything that could possibly move something, then it must have energy. Sometimes I tell kids energy is something that you can have, and work is something that you can do with that energy. So I hope that helps you have a better understanding of what energy is and what work is. Maybe as I go through these other things on my to-do list, it'll get a little better still. So second on my list, can energy be lost or gained? The answer, actually, your gut might tell you that the answer is yes, energy can be lost or gained, but you would be wrong. Energy can never be lost and it can never be gained. Now, we can take energy and we can convert it. We can move it, but we can't make it and we can't destroy it. So how much energy there is in the universe is how much energy there is in the universe. There's no more being made and there's none being destroyed. Who figured that out? This guy. His name is James Joule. He figured this out by doing lots of very tedious experiments. I think a better way to visualize this conservation of energy idea is to look at something like this. So here we have an image of the energy that goes into a car. So right here, this first yellow chunk right here, this is the gas that you put into your car. And your car does what you want it to do. It drives you around, and that is the green arrow. So if your car is about 25% efficient, what does that mean? Well, that's a later quiz, but what that means is that if you put in 100 units, and I'll get back to that in a second, but if you put 100 units of fuel into your car, only 25 of those units go into moving you around and playing your radio and headlights and whatever. The other 75% all get, and I don't want to say wasted, but they don't go to where we want them to go. So friction, losses to sound, heat, cooling the engine, exhaust gas. A lot of energy goes out of the exhaust. So you might think, well, that represents, this big red area represents lost energy, but it is not lost. It's just turned into other things that the car, that we don't really want the car to lose, but it does. We can't help it. And I should now go back and I should fix this 100 units. We actually, that James Joule guy that I showed you the picture of, he was so famous that we call the energy unit, we call it the joule. So I should have said if we put in 100 joules worth of gasoline, then 25 joules worth of that energy would go to moving the car. And the other 75 joules would have been quote-unquote wasted, I guess. So if you ask the question then, are we humans running out of energy? The answer is no, we're not. We're not running out of energy because energy can't be created or destroyed. But that's not a very good, not a very satisfying answer because of the energy that we use and where we get it from. That's where I want to go next. So up till now, where have we humans really cashed in on getting energy? We have done a lot of this. We've dug up a whole bunch of this out of the ground or pumped it out of the ground, and it has really made life pretty good for us. Oil has really done a lot for human civilization. Instead of trying to dig a ditch with a shovel, we put some gasoline into a big machine, and that can dig a ditch for us. The things that we've done in our society largely have been done because of oil. Oil is pretty sweet because it's got a very high energy density. What does that mean? That means that there's a lot of energy in a little bitty space. So oil is pretty darn awesome. But what have we humans done? We've gone far and wide. We've gone around the whole planet pretty much, and we're trying to dig up all the oil or pump out all the oil that we can. And as time goes on, it gets harder and harder to find. You know, prices eventually are going to go up, and we see that now. It fluctuates, but what happens when this is gone? You know, we're going to have to try and get energy from someplace else. So you know, we're working hard at trying to get solar panels going, getting energy from the sun. Not as much energy density because that sunlight is spread out so much, but there's still a lot of energy there, and the price is right. You know, it's free. The sun just shines. And you've probably seen wind turbines. You know, the wind blows, and we get energy from that. So we're working on kind of a way to wean ourselves off of oil in the future. And, you know, we're having some success, and it seems like all the time we're getting better at doing things like this, these renewable things. It makes me think, wouldn't it be awesome if we could harness the energy in lightning, if we could somehow take one zap of lightning and catch all that energy? I mean, there's a lot of energy there, but unfortunately it happens so fast that I think anything that we tried to put this energy in, it would just get fried. But who knows what the future brings? If you're an optimist, maybe we can someday. So what's next on my list? It says, what types of energy are there? I snooped around and I found this. And there's two broad categories that we usually talk about in science, two types of energy. One is called potential. That's what we call stored energy or energy of position. And then there's kinetic energy. That's the energy of motion. So if things are moving, then we say that they have kinetic energy. And if things aren't necessarily moving now but have the ability to make stuff move, then they have potential energy, like gravitational. If you lift something up really high and drop it, you can use that energy in that object to do work. So what's on this image? It says chemical energy, that's potential, gravitational potential, electrical potential, nuclear potential, elastic potential. Over here, kinetic energy. Sound is moving, vibrating air particles, so that's kinetic. Thermal, that's shaking air particles. Wind, light waves, electrons moving in wires, electricity. Those are all kinetic. I'm going to do my best to keep this under 10 minutes, but one thing I forgot to cover a minute ago was the energy that's in a barrel of oil. How much energy is there? I did some snooping, and I found out that there is a ton of energy in one barrel of oil. This many approximately joules. So that's 1,000, million, billion. So billions of joules worth of energy are in one barrel of oil. So I would call this, if it's scientific notation, 5.9 times 10 to the 9th joules. And how much energy is that? That is enough energy to take someone like me and take me to the top of the Empire State Building almost 15,000 times, if you could do it, you know, perfectly efficiently. So just imagine that. One little barrel of oil could take someone like me up and down in the Empire State Building almost 15,000 times. That is a very high energy density. So with my remaining minute or so, I see that I didn't talk about scalars and vectors, and I have yet to talk about energy equaling force. So does energy equal force? No, energy does not equal force. Force, remember, is a push or a pull. And so you can use force to move objects. So forces can do work. You know, if you apply a force over a distance, you're going to get work done. And to do that work, you have to have had energy. But energy and force are not the same thing. Force we measure in newtons. Energy we measure in joules. And going back to the scalar and vector idea, energy, like, well, I have a lot of energy, or there's a lot of energy in that gasoline, it does not have a direction. So energy is a scalar, and so is work. And remember that forces, those pushes or pulls, are in certain directions. So forces are vectors. All right, so under 10 minutes, that is my introductory video on energy.